with Robinhood. So HSM is becoming stronger, so more customers they have that implemented. So it's a big topic. Most of the implementation that we see so far, they are based on tape. So they are based on tape or scaled out NAS. So this is the traditional idea. We have our parallel file system in production, and then we can move the data to tape. So what we present here, so we think that object storage is a faster solution that can take a step further on that direction, so we can use that to archive data. At the time, it has an easier way to manage. And of course, with object storage, we can to deliver a simple data recovery. So because of that, and because we have already the infrastructure in place, so we have the HSM project, we have Robinhood, so we decided just for us to be as easier, implement a new copy tool, in that case to talk with an object storage. This is our approach. So what we are going to talk about this implementation, this is a project on its early stage, so we are developing now and we are doing some initial testing. So here we'll present, I'll present as well, a comparison between that and another implementation to move data to object storage, but in that case that was based on GFS. So HSM idea, most of you are already familiar with that. So we have a file system in production, we have a number of directories and our files, and of course, as long as this file system is on production, most of the data, they are not used on an everyday basis. So we use the archiving to save space on Lustre, to have a copy, a save for backup copy. So the main movement that we do is to archive data. So we copy the files to the tape, and we can release the data. Like for example, some data that we have already on the tape for security, then we can just free the space on our file system when we need it. So, why we introduced the idea to use an object storage to that? So mainly, we want to try to eliminate the higher latency that the tape has actually, and the lower throughput. With object storage, we can have already an approach where we can save the data on our object storage, and the object storage is defined to be able to have several copies across several sites. So we have a data backup and resilience across different locations. Sorry. With object storage, we can define policies and we can decide how we want to distribute the data, where we want to copy the data. So normally we could have ideally our production system, our file system running, our object storage in place, so we can do a fast copy of our data or fast move of data, and then at the time asynchronously we can move data to a second or third location. Object storage is designed to have a higher scalability, so we can scale capacity as much as we need. Sorry. And it's at the time optimized for lower cost. So this is the example, this is the system that we use for testing. This is just an object storage that we have at the end. So it's an object storage. Basically what it offers is a platform where we can put objects on there, and it could be a file from our file system. We can recover the file after, we can get the file, and we can delete it. As I mentioned, on our object storage, we can have the nodes distributed geographically, so we will have part of our system ideally on our main location, and then we can have the system distributed, so we can have a second or third copy on another location. That is very simple. So when we put information on an object storage, we save, in our case, a file, and what we get is an object ID. And this object ID, this identifier, is what we need in case we need to recover the information that is on the object after. And associated, when we write to WAS, to this object storage, we put a file on there, we just specify the IP of the system and the policy. Policy is just the way how it's defined, how we save the information. So, how much copies we want to create, where must be these copies, and how are created. If we use synchronous replication, asynchronous replication, well, how these copies are saved and so on. Okay. So that was the overview of the object storage. I hope it's a very quick overview. It's not intended to just give more details about that. So what we have tested. So we have done an implementation of the WAS copy tool, and this is and after we have tested. So on our test environment, what we have set up is we have our Lustre file system, our standard file system is here on the right of the picture. So this was a small Lustre file system where we was running a couple of OSS servers. These OSS servers, they were acting at the time like NDS servers. So the storage had a number of nearline SAS drive for the OSTs and a few SSD drives for the metadata target. These servers are attached to the InfiniBand fabric, and we have a number of clients. So we configure a few Lustre clients that they were pure Lustre clients, and a few client agent Lustre clients where we run the copy tool. They are going to do the movement of the data. And we have the object storage. In our case, it was just a small system running with only 2 nodes. Each node has a number of 30 drive. So the connection of the Lustre file system is all InfiniBand, and then the agents that do the movement of the data to the object storage, they are connected via 10 gigabit links. On the object storage side, we just have 2 nodes with one 10 gigabit single link per node. So this is a very small setup. It was a kind of initial validation testing. The test has been done on this environment, so we run it a different file system, parallel file system here, GPFS as well. We run it agent with HSM for GPFS, so we move the data to WAS. This is already a solution we have implemented, and we did a comparison how the system that we have already in production on some customer place and the new development that integrates with Lustre to see how it looks like. So, which operation have we tested in here? So initially, just to have a baseline of the system, we do some general benchmarking of the file system for both GPFS and Lustre, just to the drive, just to have a baseline numbers. Once we fill the file system with some data. What we simulated was to create small files to see how that how behaves with the small files, with medium files of 1 megabyte size and larger files around 100 megabytes. So that was the kind of 3 different tests we do. So we do the movement, the archiving of this data. So we archive a large number of small files, a large number of medium files, and a large number of big files. As they have just presented here, well, we mentioned now, so how to benchmark that is a bit tricky. Well, let's see how, I will comment how we have done it so far. And then what we do is when we have archived the data, we release the data, so we remove all the data blocks on the Lustre file system, and then we tested how, at which speed we were able to recover that information from the whole system, and we compare that. For this initial testing, read and writes on parallel file system, we just use the FIO benchmark tool to archive the data, because it's not a synchronous process that we can easily benchmark. What we do is to create, we are using the Robin Hood setup, so we did the movement of all the information and we were monitoring the system. So when the movement started, when finishes, and we were getting stats from all the agents. So what we did was to calculate the aggregate, and we get a median value, an average value of the traffic that we have during the movement. We do the same with both to get an idea of how the system was behaving. So this is not really at this level. It's not maximum performance, but we wanted to get an idea about the average that the system is able to manage actually. If you are familiar already with Robin Hood, they have explained it about the HSM commands. The WASP copy tool that we have implemented is very similar to the POSIS copy tool, so we follow the same nomination, we said not the same, similar operation. So when we run the copy tool, we can run it as one at a time, or we can run on a demo mode. And mainly when we run the copy tool, what we specify is the IP of our storage system and the policy. So with that we say where we are going to save the data and in which way that information is going to be saved. With this copy tool, the data is going to be archived or released, depending what we define at Robin Hood level. And then once the file has been archived, we can check the extended attributes of the file, and we can see that what we saved internally is this object ID. So the object ID is what we need to recover the information that has been saved on the storage system. So the WASP copy tool data flow is the general HSM data flow defined for Lustre. So running on the NDS, we have the coordinator agent, and then we have one or a multiple number of copy tools running. These are called agents. These are the Lustre clients. They're going to do the movement of the data. When they get the operation that has to be accomplished from the NDS server, they will use internally the put or get operation to put the information or to recover the data. So we have seen the test environment that we have tested. This is the data flow, and then what we have got. So here we have a few slides about the results that we have got. This is, for example, here we were testing a number of 4 Lustre clients, running single thread of FIO, doing sequential IO, writing or reading a file. Well, we know, so we have higher performance on GPFS on single thread, on Lustre numbers. So GPFS and Lustre numbers is all IB connectivity. Then the archiving numbers, these are all over 10 gigabit. No, it's the network that we have to the storage system. And we can see here already that on writes, so archiving data to WOS that we are using on the WOS side, the same API. Lustre is providing already our WOS copy tool implementation, better performance, that looks very nice. On reads, because these are sequential operation when we run with the system that was a bit lower, so on single thread. But numbers for archiving, they were very good. It's around 1.5 gigabytes per second. We have only 2 10 gigabit links on the WOS node, so we are getting maybe 80% or 75% already of the overall bandwidth. Here we have a second slide. Excuse me, a big gap, so this number is wrong. But well, if we just forget that left side of the diagram, and we focus on the archiving numbers. This is we run here 4 clients, multiple threads, so archiving data and recovering data. So that has been deleted from the file system. So when at that level, when we are reading that information, has to go to the object storage system. So the numbers for both the WOS copy tool, our Lustre implementation, and the one for GPFS, they are very close. And yeah, I said already, this is a very early stage of the project, so numbers look quite promising. Looking to the maximum performance that we were able to get using just one single client. So single client trying to maximize performance, our implementation to integrate with Lustre, they were already good. We were getting about 400 megabytes writing and reading for the system. And you have seen this is a very small setup. We just use one object storage system. We measured as well rates for small files. So the previous results I haven't mentioned. We were using 1 megabyte files and 100 megabyte files. Here using just 4K files. This is the rate, so the number of files per second, an average that were moved to the object storage. We can see that, for example, archiving small files with this implementation for Lustre, we were getting already around more than 400 files per move per second. That it was higher already than another implementation that we could say so far is a bit more mature. And the reads are nice as well. Again, we saw some results for multiple clients running medium and large files movement of data. So we have on the Lustre implementation on medium files, 1 megabyte files is even better than what we had before. What we have with the implementation we were comparing with, and on larger files was not at that level, but was quite okay already. So we are getting, yeah. So reads, we have room to improve on reads, that's right, but we are really on the early stage of the project. So we run testing with one client for client to see how the scaling is, and we saw that it's scaling. We got over 3 times bandwidth using nearly 4 using 4 clients. So the numbers looks very good. So to summary, so what we did though is a very simple implementation, relying already on the HSM project. We have so the roadmap to continue testing, of course. So this was like kind of initial validation test. We'll do scalability tests with really larger system, larger object storage to see how the number is scaled. Investigate how we can improve reads performance, for example. And we have, as I mentioned, an object storage. So the idea of the system is not only to have a copy of data, but as well distributed across sites. So at that level, we have a large room to experiment about different data protection options. So how we choose what is the best option to protect the data and to do copies to asynchronously to a second place or a third place that at the time deliver good performance, not to keep up with the system. And one of the, is not in this list, but the restore of files that they have been deleted, as they mentioned just in the previous presentation, is something that is on the we have been discussing as well. So even if someone deletes files, how we can keep track of that and recover. So because the information must be saved somewhere.